Okay, today we're going to look at lesson 1.2. This is your real number system and the property of real numbers. A real number system is literally every single number you can think of. Every number. It can be negative, positive, a decimal, a fraction, a square root, a whole number, literally absolutely anything. The craziest number you can think of off the top of your head is a real number. This is every number in the real world. Everything in this box that we're about to go through is a real number. You have two sides to it. You have a rational side and an irrational side. Your rational numbers, we'll start on this side because it's our biggest, most popular side. Your rational numbers are fractions, every single fraction you could think of, 2 over 3, negative 5 over 4. You can get crazy with it, make some really big numbers, but every single fraction you can think of is a rational number. It is also decimals that end like 2.5 or 2.67, or decimals that repeat like 2.3333 forever. Sometimes you'll see it as like 2.3 with a line over it. That means it's repeating. So the decimals that end or the decimals that repeat. The repeat could also be a pattern, like 2.145145145, and it just repeats a set of numbers over and over again. That's also a repeating decimal. So fractions and repeating decimals. Everything under this, your integer, whole numbers, natural numbers, these are all rational as well. And I'll explain why in just 1 second. Sorry, alarm's going off. Okay, integers are, they can be positive and negative, but they have no decimals or fractions. These are just regular numbers, like -3, -2, -1, 0, 1, 2, 3, forever on either side. They can be positive, they can be negative, they go on forever, but there's no decimal and there's no fraction. Whole numbers are just the positive side of that. Well, 0 up to the positive side of that. So 0 going forever. No decimals, no fractions, no negative. So 0 and up. Your natural numbers, those are your counting numbers. Like if you start counting naturally, start counting your fingers. Where do you start? 1, 2, 3, 4, 5, 6, 7, etc. Those are your counting numbers. It starts at 1 and it goes up forever. No decimals, no fractions, no negatives, no 0. The only difference between whole and natural is that 0. 0 is a whole number. It is not a natural number. I like to call it, the reason you remember it's a whole number is because you can have a whole lot of nothing. And that's what 0 is. It's nothing. So you can have a whole lot of nothing. If that helps you remember, 0 is a whole, but not a natural. Because we don't count with 0. Now, all of these numbers are rational, integers, whole numbers, and naturals. They're all rational, even though they're not fractions or decimals that end or repeat. Technically, I could change any of these numbers to a fraction, like 3. You see 3 in every single one of those lists? How do I change that to a fraction? Put it over 1. Now it's a fraction. How would I change it to a decimal? 0.0. Like if you had $3, 0.00. That is still a decimal. It is still an integer, whole number, rational number because we don't need the zeros. But they all fall under rational. Now, an irrational number, these are decimals that never end or repeat. Like, just any random number, 1.2, 3, 4, 5, 6, 7, 8, 9, etc. It never stops, it never repeats. You just put any random number out there. Just list numbers. Put that ... to show that it never ends. They're never repeating. None of that stuff. Now, if you do have just a random number that like repeats, like if I did 59996284, the repeat means it has to repeat forever. This repeats for a second, but it doesn't go forever. So that is not that falls under irrational, not rational. Now you have some special classifications for irrational. Y'all have heard of pi before in middle school. Pi, y'all learn in middle school, is 3.14. That is not 100% accurate. Pi is a decimal that never ever stops. They round it off for you in middle school so it's easier to work with. We don't do that in high school. This actually goes forever, and you can look it up. It just lasts forever, whatever. It's actually 3.14159265 something. It goes on forever and ever. So this is an irrational number. Also, square roots that you don't know, like the square root of 2. If I don't know it, that means it's a non-perfect square root because it doesn't come out to a whole number. Like square root of 4, that comes out to 2. Square root of 2, I don't know. If you put it in your calculator, you're going to get 1.41421356 something. So it's going to go forever and ever, and it's never going to repeat. It's never going to stop. So your non-perfect square roots, the ones that you don't know, that give you crazy decimals, those are irrational. So we'll come back to this list throughout the lesson to make sure we understand what is what. So let's try to classify some. So every number you can think of is real, so they're all going to fall under a real number. We need to figure out if they're irrational. If they are irrational, that is all they are. If you notice on the irrational side of our table, there weren't little sub boxes. Like on the rational side, we also had integers, wholes, and naturals. Irrational does not have any boxes underneath it because it is all by itself. So if you put irrational, you never put anything else. If it is rational, then you need to go down this list. If it's rational, would it also fall under an integer, a whole number, or a natural number, or multiples? Okay, so let's look at this one. Negative 2/3. We got to decide. Is negative 2/3 irrational or rational? You have to pick one. Have to pick one of these. Just one and only one. Rational or irrational? Where would a fraction fall? If I go back up to my table, this is going to jump. A fraction is on my rational side. So this, negative 2/3, is a rational number. If it's rational, I'm going to go down the rest of my list because rational also includes these other boxes. So if it's rational, I need to check them in order. Is it also an integer? An integer has positive and negative. So we have a negative, that's fine. But we can't have a decimal or a fraction. This one is a fraction. Can I simplify it? No, there's no number that goes into both 2 and 3. So this doesn't simplify, so it's not an integer. If it's not an integer, it's not going to be a whole number or natural number either. Because if you look at these lists up here, let me get a different color. The 1, 2, 3, 4, those are also whole numbers. The 0, 1, 2, 3, 4, those are also integers. So it'll follow up the list. But on your integer side, this negative, that did not carry down. So once I hit a stop on integer, it's not going to carry down to the other numbers as well. I am done. Once you hit a stop on one of these words, one of these categories, you are done. and you don't have to keep going through the list. If it's not an integer, it's not going to be anything else. So let's try this one. Negative 27 over 9. Where do fractions fall? Well, we just talked about that on the last one. Fractions, are they irrational or rational? You have to pick one of these. They are rational. If it's rational, I need to go down the rest of this list. Is negative 27 over 9 an integer? Now remember, my integer category said positive or negative, but no decimals and no fractions. This is a fraction, but can I simplify it? What is 27 divided by 9? That is going to be negative 3. Is negative 3, does it fall under the category of integer? Is it positive or negative with no decimal and no fraction? Yes, we even had that on our list just there, negative 3. So it is an integer once I simplify it. We always have to check to see if they simplify. Then I can keep going. Is it a whole number? Remember, whole numbers are no decimal, fractions, or negatives. So is negative 3 a whole number? No, because it has the negative. So if it's not a whole, again, that's my stop, so I don't keep going. If it's not whole, it's not going to be natural either. Okay? Look at the next one, 3.235. Remember, you have to pick rational or irrational. Is 3.235 ... that means it keeps going forever. Is that rational or irrational? Now, it is a decimal. Decimals fall under both categories. So is this a decimal that does end or repeat, or is it a decimal that never ends or repeats? Well, it doesn't end, and it doesn't repeat, so this is irrational. And remember, irrational stands alone. It's not going to have these other categories. So that is it. If you pick irrational, you're not picking anything else. So 4 1/3. Is that irrational or rational? Where do fractions fall? Fractions are always rational. If it's rational, go down my list. Is it an integer? Remember, integers were no negatives. Sorry, they could be negative or positive, but they have no decimal and no fractions. Well, this one has a fraction, so it's not an integer. And that's my stop, so I don't keep going. That's where I'm going to end. Okay, negative square root of 2. Rational or irrational? Do I know the square root of 2? No. Remember, your non-perfect, I actually gave you that example. Your non-perfect square roots that give us crazy decimals, these are irrational because those decimals are never going to stop or repeat. So this is irrational. Remember, if I put irrational, I don't put anything else. Okay, 4.56, and that little line means it's repeating. So where do repeating decimals fall? They fall under rational. If it's rational, go down my list. Is it an integer? Remember, integers were positive or negative, but no decimal or fraction. So does this qualify? No, because it has a decimal. It is not an integer. So that's my stop, so I don't have to keep going. Okay, square root of 4 over 49. Remember, if it's a square root I don't know, it's irrational. But if it's a square root I do know, it's rational. Like square root of 4, that's 2. 2 is a rational number because it's a normal number. So which one is this? It's kind of weird because we have a fraction here, but square rooting a fraction is pretty basic. You're going to do the top versus the bottom. What is the square root of 4? Well, I know that. I know the square root of 4 is 2. What is the square root of 49? I know that one as well. The square root of 49 is 7. So this is my simplified version. I did know the square root of it, so that makes it rational because it's still a fraction. If it's rational, go down my list. Is it also an integer, which means it's positive or negative with no decimal or fraction? No, because this one has a fraction. So it is not an integer. That is my stop, so I don't have to keep going. Okay, the 2 over 3 squared, is that irrational or rational? Remember, fractions are rational. So then I go down my list. Is it also an integer? No decimal or fractions. Well, it has a fraction, but we can also square it. So let's see if it simplifies. What is 2 squared? 4. 3 squared is 9. Does 4 over 9 simplify? No. Nothing goes into 4 and 9. So I can't simplify it, so it's not an integer because it stayed a fraction. So that's my stop, so I don't have to go any further. Okay, 0 over 6. Well, it's a fraction, so what does that mean? That means it's rational. Is it an integer? Can I simplify that fraction? What is 0 divided by 6? 0 divided by everything is 0. So does that fall under integer? Remember, integer could be positive or negative with no decimal or fraction. When I simplified it, did it have a decimal or fraction? No. So this is an integer. So let's keep going. Is it a whole number? So we haven't seen whole in a second. Whole numbers had no decimals, no fractions, and no negatives. Does this have a decimal, fraction, or a negative? No. So this is a whole number. Remember I told you whole numbers, you could have a whole lot of nothing. That's what 0 is. It's a whole lot of nothing. So that is whole. And then the last one is natural. Natural are your counting numbers. So do I count with 0? Remember when you start counting your fingers, where do you start? You start at 1. 1, 2, 3, 4, 5. So do we count with 0? No. So this is not a natural number. So that is your chart. Okay, next example. Which expression does not name an integer? Remember, integers could be positive or negative with no decimal or fraction. So is negative 15 an integer? Yes, because there's no decimal or fraction. We want the one that is not an integer. Is 0 an integer? Yes, because there's no decimal or fraction. Is 6 over 14 an integer? Not quite. It is a fraction. Let's see if we can simplify it. What goes into 6 and 14? 2. So if I divide 2 out, 6 divided by 2 is 3. 14 divided by 2 is 7. Does it simplify anymore? No. So that is not an integer. So I'm going to say that's the answer for now. Let's double check this last one. This last one is a fraction as well, but I can't have 2 answers, so let's see if it simplifies. What is 12 divided by 6? Does that simplify? Yes, 12 divided by 6 is 2. So that comes out to a whole number, which is an integer as well, because there's no decimal or fraction. So that one actually does work. So our answer is B. Which expression represents an irrational number? Remember, your irrational numbers are decimals that never end or repeat. They can also be those non-perfect square roots, the ones we don't know, or pi. So 0.18 with that repeating line over it. That one's going to repeat because of that line, so that is rational, which is a Q, not an R. Rational is a Q. 2 over 3. Remember, fractions are rational, so that can't be irrational. Square root of 75. Do we know the square root of 75? Nope. So that one is irrational. But let's check this last one, because I don't know the square root of 3 either. So why is that one not irrational? Because it's subtracting square root of 3. Just like 3 minus 3, that's 0. When you subtract something by itself, it's always going to be 0. It doesn't matter if it's a fancy square root. Square root of 3 minus square root of 3 is still going to be 0. 0 is a normal rational number. So the answer is B. Okay, which number is not a whole number? Not a whole number. Remember, whole numbers start at 0 and they go up. There's no negative, no decimal, no fraction. So is 8 a whole number? Yes, because there's no decimal, no negative, no fraction. What about 0? Yes, remember you can have a whole lot of nothing. What about negative 10? No, because of that negative. So this one's probably the answer, but let's double check. What's 18 over 3? That's a fraction. So why is that a whole number? Because I can simplify it. 18 divided by 3 is 6, which is a whole number. So our answer here is B. They've all come out to B so far. That's kind of weird. Which of the following is a true statement? Is negative 9 a whole number? No, because whole numbers can't be negative. Is 0 a rational? Oh, wait, sorry, I skipped B. Is square root of 25 an irrational number? No, because I know the square root of 25. Square root of 25 is 5. That one works, so that one's rational. Is 0 a natural number? Remember, naturals, you're counting. Those start in 1, 2, 3, forever. We don't count with 0, so that is wrong. Is 2/3 a rational number? Yes, all of your fractions are going to be rational. Which of the following statements, I should say is false? So we want false this time. All real numbers are rational. So I'm going to draw the chart over here just so we don't have to flip back and forth. So this is my real number system. You have your rational right here, which is represented by Q. Irrational on that side. Underneath rational, we have integer, whole number, and natural number. So are all of these real numbers, this whole box is real numbers, are all of them rational? No, half of them are rational, but the other half are irrational. So that is false. Not every single real number is going to be rational. Like pi, for instance. That's not rational. So that is false. So that should be our answer, but let's double check. Are all natural numbers integers? We got our naturals right here, integers above it, and yes, all of your natural numbers are integers because they are enclosed in the integer box. Remember, integers are -3, -2, -1, 0, 1, 1, 2, 3 forever. Natural numbers start at 1, 2, 3, and go on forever. So all of those natural numbers are also on the integer number line. So that is true. Is every integer a rational number? Yes, because it is on the rational side of the box. Because any integer, no matter what it is, like -5 or 2, I can make it a fraction by putting it over 1. So those are rational. So that is true. Is every whole number a real number? So your whole number, is it a real number? Yes, because this is the real number box. Everything in it is a real number. Every number you could possibly think of off the top of your head is a real number. So the only one that was false was E. Okay, give an example of a number that is whole but not natural. Remember, wholes were the 0, 1, 2, 3, etc. Natural is your 1, 2, 3, etc. So what is whole but not natural? There's only one, and that is 0. 0 is the only difference. We talked about that on the last page. 0 is the only difference between whole and natural. Okay, give a real number, so any number in the whole world, that is not rational. Well, if it's not rational, what does it have to be? If it's not on this side of the box, it has to be on the irrational side. So give me an irrational number. That could be anything from pi to square root of 2, which I gave you on the front page, or square root of 3. Or just put random numbers down and make a decimal that never ever stops. 2, 5, 9, ... Never repeats and never stops. Give an example of a rational number that is not an integer. So we want a rational number, which are your fractions, your decimals that never stop or repeat. Sorry. They do end or they repeat. But we don't want it to be an integer. Your integers are those whole numbers, negative and positive, without decimals and fractions. So we need a rational number that is not an integer. So that can be a fraction, like 2/3. It could be a decimal that ends, like 2.5. Or it could be a decimal that repeats, like 2.3333333 forever. So any of those are valid answers. Okay, so let's see if we can do some more. Place a letter for each value in all of its locations in the real number system below. So this is our real number box. We got our rational over here by itself. Irrational. And then our rational with all of its subcategories. So where does 7 fall? Is 7 rational or irrational? 7 is normal, so it's rational. So A is going to go here. If it falls under rational, keep going until you hit a stop. Is 7 an integer? Yes, because there's no decimal or fraction. Is 7 a whole number? Yes, because remember, whole numbers are 0, 1, 2, 3, etc. Is 7 natural? Do we count with it? 1, 2, 3, 4, 5, 6, 7. That's a natural number. Okay, what about B? Negative 36 over 12. Where do fractions fall? Fractions fall under rational. So if it's rational, keep going down the list. Is it also an integer? Fractions are not integers, but can I simplify it? Yes, negative 36 divided by 12 is negative 3. Negative 3 is an integer. Because remember, your integers are like negative 3, negative 2, 1, 0. We can't see that anymore. 0, 1, 2, 3, forever. Okay, is it a whole number now? So it was an integer, but is it a whole? Remember, wholes start at 0. They don't have decimals, they don't have fractions, they don't have negatives. So it is not a whole number. So that is where I stop. I don't keep going. That's my stop. Okay, C, negative square root of 36. Square roots you have to watch. Do you know the square root of 36? Yes, square root of 36 is 6, and I'm going to bring down that negative. That is a square root I know, so it is not an irrational. It's going to fall under rational. Then I go down the list. Is negative 6 an integer? Yes, because there's no decimal or fraction. Is it a whole number? No, because it has a negative, so that's my stop. Okay, D, pi. Where does pi fall? Pi is one of those decimals that never repeats or never ends, so that is irrational. It's one of those special categories. If it's irrational, it's nothing else. It just is there. 6.48. That is a decimal. Both sides have decimals. But this decimal stops. Which one stops? Irrational or rational? You're irrational. So is it also an integer? No, because integers don't have decimals, so that is where I stop. Okay, F, -2, is that irrational or rational? That's a normal number, so it's going to be rational. Is it also an integer? Yes, because there's no decimal or fraction. Is it also whole? No, because it has a negative, so that's my stop. Negative square root of 10. Is that irrational or rational? Do I know the square root of 10? I don't know the square root of 10. So that's going to fall under irrational. So if you were to check that out in a calculator or something, you would get a really long random decimal that doesn't repeat and it doesn't end. Okay, H, 0. Is that irrational or rational? That's normal, so it's rational. Is it an integer? Yes, because there's no decimal or fraction. Is it a whole number? Yes, because there's no negative or decimal or fraction. Is it a natural? No, because I do not, because we do not count with 0. Naturals start at 1, 2, 3, forever. Okay, I, 2 and 1/6. Is a fraction irrational or rational? It is rational. So is it an integer? No, because it has a fraction. So that's where I stop. J, -0.7 with a line. That line means repeating. So where do the repeating decimals fall? Those are rational. So is it also an integer? No, because it has a decimal. So that's my stop. Okay, and the last one, square root of 4/81. Is that irrational or rational? Do I know the square root of this? I do know the square root. I just have to do the top and the bottom separately. Square root of 4 is 2. Square root of 81 is 9. I do know the square root of that, and it's still a fraction, so that is rational. So is it an integer? It's a fraction, which would tell me no, but can I simplify it? No. There's nothing that goes into 2 and 9, so this is not, you can't simplify it, so it is not an integer. So that is where I stop. So this is what your table should look like for this example. Okay, so let's see if we can classify these. This is what it's going to look like on a test, a quiz, a bell work, or any of that stuff. So you'll just have a number and you'll just write out the letter that it belongs to. So remember, you're going to start with irrational or rational. You have to pick one and only one. If it's irrational, you're done. If it's rational, you have to go down this list. This is only, oops, it's not writing anymore. Only for rational. So let's look at 30. Is 30 rational or irrational? That is rational because it's just a normal number. We could make it a fraction by putting it over 1. So that is rational. If it's rational, go down your list in order. Is it also an integer? Yes, because there's no decimal or fraction. Is it also a whole number? Yes, because there's no decimal, fraction, or negative. Is it also a natural number? Yes, because eventually I could count up to 30. 1, 2, 3, 4, 5, all the way up to 30. So that is the 4 rational sides. The 4 under rational. B, -11. You have to pick irrational or rational. That is rational. So go down your list for rational. Is it an integer? Yes, because there's no decimal or fraction. Is it whole? No, because it has a negative. So that's my stop, so I don't have to keep going. Okay, C, 5 and 4/7. Is that irrational or rational? Fractions are always rational, so go down your list. Is it an integer? No, because it has a fraction. Can I simplify that fraction? No, nothing goes into 4 and 7, so that is it. That's my stop. Okay, D, square root of 21. Do I know the square root of 21? No. So that is going to be irrational. If it's irrational, it is nothing else. So we are done. E, rational or irrational? 0 is rational. It's Q. I could make that into a fraction if I wanted to. So then go down my rational list. Is it also an integer? Yes, because there's no decimal or fraction. Is it whole? Yes, because there's no negative or decimal or fraction. Is it natural? No, because I don't count with 0. Okay, negative square root of 9. Do I know that square root? Yes, square root of 9 is 3. I'll carry that negative down. I know the square root, so it is rational. Is it also an integer? Yes, because there's no decimal or fraction. Is it a whole? No, because it has a negative. Okay, G, 6 over 3. It's a fraction, so where do fractions fall? Those are rational. Is it also an integer? It's a fraction, so you would say no, but can I simplify it? Yes, 6 over 3 is 2, which is an integer. So is it also a whole number? Yes, because there's no decimal or fraction or negative. Is it also a natural number? Yes, because I count with 2. 1, 2. Last one, 5.3 with the repeating line. Where do repeating decimals fall? Under rational. So is it also an integer? No, because integers aren't allowed to have decimals. So that is it. Okay, the last thing we're going to look at are properties. These are properties that we can use when we're solving equations. You'll see these a lot throughout the year. We have 7 of them. So the first one is your commutative property. This is going to change the order of your problem. It keeps it the same. It's still equivalent if we change the order. So A plus B is the same thing as B plus A. Like for instance, 2 plus 3 is the same thing as 3 plus 2. They're both going to be 5. It doesn't matter which order they're in. They're both going to be 5. This only works for addition and multiplication. These do not work for subtraction or division. Only for addition and multiplication. We shorthand this instead of writing it all out. We shorthand it with CPA, commutative property of addition. If it's multiplication, it's CPM. But whether it's addition or multiplication, it's just changing the order. Like for multiplication, 2 times 3 is the same thing as 3 times 2. They're both going to be 6. It doesn't matter which order you put it in. For associative property, this one is going to have a change in grouping, which is your parentheses. So you have your A plus B in parentheses over here, and the C's outside. On the other side, A is on the outside, but B and C are on the inside. It doesn't matter where the grouping is if we're adding or multiplying, because it's always going to come out to be the exact same thing. Like, I'll give you an example. If we do 2 times 3 times 4, or 2 times 3 times 4. 2 times 3 is 6, times 4 is 24. On the other side, you have to do your parentheses first. 3 times 4 is 12, times 2 is still 24. Doesn't matter where the parentheses are with addition and multiplication, it's going to be the same answer. So associative, their shorthand is APA, associative property of addition, or associative property of multiplication. So you can write those shorthands. Identity property means your number does not change. So the term does not change. It looks a little different. For addition, if you add 0 to something, it's not changing it. 2 plus 0 is still 2. That does not change. For multiplication, it's multiplying by 1. 2 times 1 is still 2. That does not change. So that's what identity property is. It's like your ID. You are who you are. You can change your hair, you can change your clothes, you can change your makeup, whatever, but you are still you. Your DNA is still you. You are not changing. So that's your ID. That's your identity. Yeah, so for addition, it's adding 0. For multiplication, it's multiplying by 1. So identity property of addition is IDPA. IDPA, yeah. Identity property of multiplication is IDPM. We put the ID there because we have 2 I properties, so we have to classify which I is which. Inverse means you're doing the opposite, and it's going to cancel out. So what's the opposite? And it cancels. So for A, we'd have to add the opposite, which is negative A. So like 2 plus negative 2. That's going to cancel out to 0. For multiplication, you have to do the reciprocal, which is just flipping the fraction. So if I give you 2, you have to multiply by 1 over 2. That'll give me 2 over 2, which cancels out to 1. So inverse is going to cancel it out. Inverse of addition is INPA. Multiplication is INPM. Zero product property. You can multiply anything by 0. Multiply anything by 0, and the product equals 0. So like negative 5 times 0 is 0. Negative 4 times 0 is 0. 3 times 0 is 0. It doesn't matter which multiply by 0, it's going to be 0. So zero product property is ZPP. This is not for addition. This is only for multiplication. Only for multiplication. Multiplication property of negative 1. This is also only for multiplication because you're multiplying by negative 1. If we multiply anything by negative 1, the product, the answer, is the opposite. It doesn't matter what you start with, it's going to be the opposite. So if I do negative 1 times 2, the opposite of 2 is negative 2. If I do negative 1 times negative 3, the opposite of negative 3 is positive 3. It's going to be the opposite. It doesn't matter what you start with. We label that with MP, multiplication property, negative 1. So multiplication property of negative 1. Distributive property, this one's only for addition and subtraction. You have some multiplication in it when you distribute it out, but this one actually does work for subtraction. But this one just says you're going to distribute the outside term. So like that A on the outside, you're going to distribute to everything on the inside. On the inside of the parentheses. So we distribute that A times B gives us AB, A times C gives us plus AC. A times B gives us AB, A times negative C gives us negative AC. So with numbers, to make it make sense, 2 times 3, I multiply it by that, it gives me 6. 2 times 4, negative 4, gives me negative 8. So you're just multiplying by everything inside. We label that as DP. There's no addition or multiplication added to the end of that because technically it's both. You're multiplying and you have addition or subtraction. So we don't have an A or an M at the end of that. Okay, so let's see if we can figure it out. So name the property of real numbers illustrated by the each statement. So for A, what changes from the left side to the right side? Well, anytime you have parentheses, I would say look at those parentheses first. What is inside of them? On this side, we have M and 7.3. On this side, we have 7.3 and 4.1. So what changed about those? Did those parentheses change? Yes, and our change in parentheses in our group, that is associative property. That changes our parentheses. So that is associative property. We are adding. So this is associative property of addition, APA. B, 5p times 1 equals 5p. What changed here? Nothing. 5p stayed 5p. We multiplied by 1, but it did not change. What property does not change? That's your identity property. That's your ID, who you are. When I add 0 or when I multiply by 1, it does not change the number, the term. So this is my identity property, and this is multiplication. So M. Okay, C. 12x plus 4y plus 0 is 12x plus 4y. What changed from the left to the right? Nothing. I added 0, but absolutely nothing changed here. It stayed 12x plus 4y. So same thing. This is your identity. You can add 0 to yourself, but you're still you. That's your identity property. And this is addition. So this is A. IDPA. Okay, D. What changed from side to side? Your parentheses here, they flipped. They changed in order. Over here, 3R came first. On the right side, 2S came first. Which one changes in order? The first one, commutative. That flips your problem around. Yes, it is parentheses, so you would kind of think it changes your parentheses. But when we look at associative with those parentheses, what's inside your parenthesis changes completely. A is no longer in there when I go to the other side. On this problem, what's inside my parentheses is still the same. I still have 2S, I still have 3R. They just flipped backward. So that's commutative property, and this is multiplication. Okay, E, what changed from the left to the right? Again, it just changed order. What's inside my parenthesis did not change. It's still -2. It just flipped backward. Instead of 17 coming first, -2 came first. So that is still commutative property of addition. F, what changed from the left to the right? My 3. On the first one, I had a -3, and it became a +3. Why did that change? Because it's multiplying by negative. Technically, that's an understood 1. We're multiplying by -1. What property multiplies by -1? My multiplication property of -1. That's what we said here. Multiply anything by -1, and it's going to be the opposite. -3 became +3, so that is the opposite. Multiplication property of -1. Okay, G, what changed to the left from the left to the right? A lot, because it canceled out. I had 2/3. I flipped it upside down, which is its opposite, and it canceled out to 1. Which one cancels out? That's going to be my inverse. I took the opposite, so instead of 2/1, I got 1/2, and it canceled out to 1. Instead of 2/3, I multiplied by 3/2, and it canceled out to 1. That is my inverse property, and this is multiplication. H, what happened from the left to the right? I multiplied by 0, and it became 0. What property multiplies by 0? Not adds by 0, those are different. We have one that adds 0, that's identity. Which one multiplies by 0? The 0 product property. This one multiplies by 0 and makes your answer 0. So that is 0 product property. Okay, on the next page, what changed from the left to right here? The order. 35 was first, and it flipped to the back. Now x is first. What property changed the order? That's commutative property, and this is multiplication. Okay, for J, what changed from the left to the right? That P. I did have a positive P. Now I have a negative P. Why did that change? Because it's multiplying by that negative 1. What property multiplies by negative 1? Multiplication property of negative 1. Okay, K. What changed from the left to the right? Nothing. My M stayed M. I added 0 to it, but it stayed M. That identity did not change. So that is my identity property, and this is addition. M, what changed from the left to the right? Nothing. Again, that 53.7 stayed 53.7. I multiplied by 1, but it did not change its identity. That's my identity property, and this one is multiplication. Okay, so you can go and try to practice on the rest of this page for all of these, and good luck.